Okay, this is a review of your science lesson for this week, and we're looking at the section entitled How Are Light and Color Related from your science textbook, pages 474 through 478. So what we're going to be looking at, the science concept, is how light affects the way things look. That's what we want to get out of this. We have your vocabulary words, which number 1, absorbed, 2, opaque, 3, transparent, and 4 is translucent. These are going to be the vocabulary slides that you're going to be creating for your science activity for this week. Okay, and any other pertinent information that you learned in the chapter. You don't just have to do the vocabulary slides. If you want to go the extra mile, like some of you have been doing, those slides can be as well developed as you can make them. So I'm going to review the concepts from this chapter and then discuss your future assignments. So let's go ahead and get started. We're looking at light. We're looking at white visible light that we have. And the light, some objects can absorb light, like this example here. And what it means is energy taken in or soaked up by an object, like a rock. You see a rock out in the sun, it'll start to absorb the heat, and eventually it'll start getting a little bit hot. So it absorbs heat during the day and it releases the heat at night. So that's very interesting. That's an example of an object that absorbs the energy taken in. And that's this one there. That's an example. The next one is opaque. And that is one where the objects that do not let light pass through it, like a mirror. Okay, they don't let the light pass through it. They will reflect it back to the person or back into the atmosphere. A mirror is a good example of that. The next one is your transparent and translucent objects, like a glass, like a window in your car, a window out in your home, that will let some of the light pass through it. Okay, like a light bulb is also a translucent light bulb. It'll let some of the light pass through it. Now you can't see the center of the light bulb, but that's how your visible light can get separated. When we separate light, that's where you start seeing the colors of the rainbow. We're going to get to that section next. If you have a prism and you shine a white light through it with a flashlight or any white light out of the sky, it will show you each color of the light as it bends through the prism. Each color of the light comes out of the prism separate from the other, and that's how you get these colors. These are the way the colors are divided, and these are how they are organized always. It's always red, yellow, blue, light darker blue, and then violet. Okay, that's how when you see the rainbow, you always see the red on top and the violet at the bottom of the arc. So that's how we separate. That's how light can be separated. If you have a translucent prism, it'll shine through it, and then this is what you will see outside as the light comes out. So as light passes, light bends as it passes through the prism. Now each color of the light bends differently, and each color of the light comes out of the prism separate from another. Now, why do we see rainbows when the sun comes out after it rains? Well, what's happening is, just like the prism was the object that separated the light, when it rains, the water droplets become those. It's like a prism. And as that now, these two things have to happen. It has to have rained, and then the sun come out. That's when the rainbows come out. And this is a very scientific example, but I think you guys can benefit from it. So what you're seeing is the little light droplets act like a prism, and once the sun passes through the water droplet, the reflection that we get, or what we see, is the light being separated, and it all starts at a 42-degree angle. and we start seeing the colors of the rainbow. Now, this pattern is the pattern you will always see. It's a red, yellow, green, blue, and then the violet goes in here. Now, what's happening here? Well, to see a rainbow caused by sunlight, the sunlight needs to come from behind us, because the rainbows only appear in the part of the sky directly opposite from the sun. The red has the longest wavelength among the visible colors, so it tends to bend the least, and the angle between the incident of the light, which is this one here, and our sight, which is our sight here, is at 42 degrees. As a result, the red appears on the top of the rainbow. Violet, which is in here, is the shortest wavelength. It tends to bend the most. To see violet, the angle between the incident and the light and our light line of sight is roughly about 40 degrees. So violet appears at the bottom of the rainbow. Now keep in mind, a rainbow is just not this arc. It is all of this here. But we don't see this because this is the ground here. And we don't see that part because it's invisible to us. The other part of the rainbow is underground and is not visible to us. We don't get to see that part. We only see this arc here. That is the only thing that is visible to us. So again, to review, what we're seeing is we're seeing the water droplets act like the prism before, what we saw here. See how the prism acts, separates the light. This is what the water droplets are doing. Okay? And that's why we get to see that rainbow after it rains and the sun comes out. Okay? And the sun will always be behind us. And the next time you see a rainbow, look at the position of the sun. It'll be behind you and maybe the cloud where it rained, and you see them very beautifully. Now I have a very neat experiment that I did at home, and it's very simple. Okay, and what you do, all you do is you get a glass of water, a white sheet of paper that you put in front. You get the other piece of paper and you cut a little slit down the center of that other piece of paper. Now keep in mind, don't have it too wide. You want it to be a very, very narrow, not too narrow. You want it to be the size where the light will shine through it. You're going to get a flashlight that shoots out a white light. Some flashlights shoot out like a little yellowish light. Those will not work. If you have a very bright LED light, that will work. Now the key is, you're going to put that flashlight right here. You're going to shine the light through it. And as the light goes through the water is going to act like those water droplets. And it's going to separate the light into the separate colors. And this is what you're going to see. And you can't see the flashlight because of the darkness, but it's right here behind me. And I'm shining it through here. And this is what you see coming out at the end over here. That's why you have this white sheet of paper. The only key is you have to do this in a completely dark room. If you try to do this during the day, all you're going to see is white light come out. You're going to see the light shine through the slit, through the water, out the glass, and up here what you're going to see is just white light. If you do it in a very, very dark room, and I did this at about 1 a.m. last night, I shone it through put the flashlight right here, I shone the light here, and then you got to see it very faintly up here. And I had to move the flashlight up and down a little bit. I had to move it back a little bit. I had to move it around and play with it a little bit until I got this one. It took me a while, but it worked. And it was pretty neat. I was like, well, yes, it'll work. I'm going to show my students how to do this. So this is your suggested science experiment. It's very easy to do. And if you want to add this to one of your slides, that'll be great. Or if you just want to share with us what you did, that would be great also. And this is assigned on Monday. Your slides are assigned for you to do. Your vocabulary slides, I believe, are assigned on, I believe it's Wednesday. I believe it's Tuesday and Wednesday. I'm not too sure. But that is what you, I believe it's Wednesday. And you do have a brain pop quiz to work on. Now the questions that are I'm going to make the questions on the quiz, because if you go right now before the date the assignment has been assigned, you're going to have the quiz that Brain Pop gives you. And that quiz is not going to have the information being tested that I just covered right now. You have to wait to the day it's assigned for that quiz, those questions that I made show up on that Brain Pop quiz. If you go in right now and log in, you're going to watch the video and it's going to take you to the quiz that Brain Pop developed. And like you did it last time, some of those questions that they asked you did not really coincide with what you were studying in the classroom or in the text for that week. So please avoid doing that until the day the assignment has been assigned. And then to know when it's assigned, visit RenWeb. So again, hopefully you'll have some good experiences with this, and it's going to take a while and play with it, but you should be able to be successful. So again, to go back and review your vocabulary words. Now I put transparent and translucent. To me, they're synonymous. Okay, they're synonymous. It's a very, very fine line between the difference between translucent and transparent, but it's still there. It's in your textbook. You can give me one definition for each. That's fine. So these are examples of some of the slides that you're going to see for opaque, absorbed, and transparent and translucent. And that is a review of your science section for today, or for this week. How are light and color related? And we looked at how light affects the way things look. We know that some objects absorb it, some objects are opaque, some objects are transparent and translucent. We also reviewed how a prism separates lights into its various colors, and then how nature takes that same concept, and it is how rainbows, what we call rainbows, form. And again, it's the water droplets acting like the prism in the sky and then creating the sight that we see. And the interesting thing is, and remember, the rainbow is just not that arc. It is a whole, not just a 2D object, it's a 3D object, but we just don't see the bottom part because that's invisible to us. It is invisible to us. And again, you have your suggested science experiment. Very easy to do. You don't need a lot of materials, and it's quite fascinating to do. I really enjoyed doing this the other night, but it took me a while. I had to practice quite a bit. So if you're not successful the first time, just keep trying, and you'll see this. And again, play with the flashlight, moving in and out, and you'll start seeing some differences. And if you want to share this with us, please share this with us at your earliest convenience, and let me know during our live sessions if you want to share. Well, that's the review of our science lesson for this week. Again, if you have any questions or concerns, please let me know. What you do have this week is you have your vocabulary slides to do, and anything else you want to add to that presentation, and then you have your Brain Pop quiz. And again, make sure you wait for the day that it's assigned so that the quiz that I created will show up. If for some reason it doesn't let me do it after I already put the date of when it was assigned, I can't go back and change it. I'd have to redo the whole quiz all over again, and I'm not going to do that right now. So you can go ahead and take it the day it's assigned, and then so you can be successful. And it's going to cover the definitions we just reviewed today. It's going to cover explain what a prism does, and it's going to ask you how to identify how a rainbow is created in the sky. And those are the pretty much everything that we covered on this presentation that will be covered on that quiz. Well, thank you for being so attentive, and again, if you have any questions or concerns, let me know through an email or through our live sessions.